Welcome, network architects. Today we are diving into the core of NVIDIA Spectrum networking. We will master how to configure, optimize, and verify the critical features that make an Ethernet fabric AI-ready QoS, ECN, PFC, adaptive routing, and telemetry. Let's get started. Let's kick things off with the foundation of AI networking, quality of service, or QoS. As noted in the first bullet, QoS isn't just about VoIP prioritization anymore. In AI, it's about guaranteeing lossless delivery for massive GPU datasets. The basics are simple but unforgiving. Traditional Ethernet drops packets when congested. For standard web traffic, TCP recovers gracefully. But AI uses ROS, which bypasses the CPU. If an AI fabric drops a packet, it triggers a catastrophic retransmission storm that stalls your entire GPU cluster. How do we fix this? We implement a lossless traffic class using PFC and ECN. As a deep dive, the NVIDIA Spectrum ASIC gives us a massive advantage here. It uses a fully shared buffer. This means when a sudden microburst of traffic hits one port, it can dynamically borrow memory from the entire switch, absorbing the shock without dropping a single frame. Look at this flowchart comparing the two fabric types. On the left, traditional Ethernet inevitably leads to packet drops during heavy AI bursts, which immediately causes GPU stalls and ruins your job completion time. On the right, the Spectrum QoS path enables lossless ROSI of 2. By utilizing PFC and ECN, the network acts as a shock absorber, resulting in peak GPU utilization. Now we move to slide 2, focusing on priority flow control, or PFC. What is it? PFC is the brute force mechanism that physically stops packet drops. The basics are that it pauses traffic on a per priority basis. If you map ROS to traffic class 3, PFC will only pause class 3, letting management traffic on class 0 continue. Why is this necessary? Because switch buffers are finite. When the buffer is nearly full, the switch must physically tell the sender to stop. How does it do this? By firing a PFC pause frame upstream. However, look at the deep dive. Relying only on PFC is a recipe for disaster. If an AI job causes a massive bottleneck, the leaf switch pauses the spine, and the spine pauses every other leaf. This congestion spreading freezes innocent workloads sharing that priority class. PFC is our safety net, but we need a smarter tool to prevent hitting it. This sequence diagram shows the PFC safety net in action. The sender blasts a heavy ROS burst. The Spectrum switch detects its buffer hitting a critical threshold. Instantly, it sends a PFC pause frame back to the sender. The sender halts, allowing the switch to safely drain its buffer to the receiver. Once the buffer clears, transmission resumes without a single dropped packet. To prevent those dangerous PFC storms, we use explicit congestion notification, or ECN, outlined here on slide 3. What is ECN? It is an intelligent, early warning system. The basics rely on WRED. Instead of waiting for the buffer to fill up completely, WRED monitors the queue. If it starts growing, the switch alters the IP header of the packets, setting the congestion experience bits. Why? To tell the endpoints to gracefully slow down, totally avoiding the brute force PFC pause. Look at the NVIDIA sample code. It is beautifully simple to enable ECN on traffic class 3 using a single command. The deep dive reveals the magic of the Spectrum X platform. When the receiver sees the ECN mark, it fires a congestion notification packet back to the sender. If that sender is a Bluefield 3 Super NIC, it processes that CNP in hardware and smoothly throttles the injection rate in nanoseconds. Follow the loop in this diagram. The data flows from the sender to the Spectrum switch. As the switch detects the buffer growing, it marks the packet with ECN. The receiver Super NIC sees this mark and immediately sends a CNP congestion notification packet back to the sender. The sender then gracefully throttles its transmission rate, stabilizing the network. Slide 4 introduces a massive leap in fabric efficiency, adaptive routing. What is it? It is a mechanism that routes data packet by packet based on actual, real-time congestion. The basics involve moving away from legacy ECMP. ECMP looks at a packet header and hashes the entire flow to one physical path. Why does ECMP fail in AI? Because AI creates massive elephant flows. If ECMP accidentally hashes 2 of these flows onto the same spine link, you get a devastating collision, while parallel links do absolutely nothing. How do we fix this? By enabling adaptive routing in NVIDIA. The Spectrum switch constantly evaluates its egress queues. If one path is busy, it sends the next packet down a different path. The The deep dive catch here is that this spraying means packets arrive out of order. Therefore, you must pair this with Bluefield, 3 Super NICs, which instantly reorder the packets in hardware before the GPU even knows. This flowchart perfectly contrasts the two routing methods. On top, ECMP forces both elephant flows down link 1 due to a hash collision, creating a massive bottleneck while link 2 sits idle. On the bottom, adaptive routing looks at the load and dynamically sprays the packets evenly across both link 1 and link 2. Every bit of bandwidth is utilized. You cannot optimize what you cannot see. On slide 5, we cover what just happened, or WJH. What is it? It is hardware-accelerated telemetry built directly into the silicon of the Spectrum ASIC. The basics are that it inspects packets at line rate. Why do we desperately need this? Because AI microbursts happen in a fraction of a millisecond. If you use traditional SNMP, which polls every 30 seconds, it just averages the data out. The drop is completely invisible to you. How do we get this visibility? We enable it via NVIDIA, and the switch streams the data to NVIDIA NetQ. In our deep dive, the true power of WJH is revealed. When a packet drops, WJH grabs the exact header, the exact microsecond timestamp, and the exact hardware reason it dropped, like a buffer tail drop. You stop guessing and start fixing immediately. Look at the WJH pipeline. A packet enters the ASIC. If it forwards successfully, great. But if a congestion drop occurs, the packet is intercepted by the WJH hardware engine. The engine extracts the critical metadata, generates a lightweight JSON payload, and shoots it directly to your NetQ dashboard. The root cause is identified in real time without digging through debug logs. Let's tie all of these features together in a highly critical real-time use case. Imagine you are training an advanced mixture of experts large language model. You hit the all-to-all synchronization phase. Suddenly, 40 GPUs try to send massive data bursts to a single receiving GPU at the exact same microsecond. This is a severe encast. The top-of-rack switch buffer starts filling dangerously fast. Step 1. Because you enabled WJH, NetQ instantly flags a spike in queue utilization. Step 2. Because you configured QoS properly, the Spectrum switch does not drop packets or send a PFC pause. Instead, it marks the packets with ECN. The receiver fires CNPs back to the 40 senders. Step 3. The sending Super NICs gracefully throttle their speeds. The microburst is completely smoothed out, the fabric never freezes, and your expensive AI job continues at maximum efficiency. This sequence diagram maps the exact resolution of the encast event. The massive burst hits the Spectrum TOR switch. The switch marks the packets and WJH records the spike. The receiver gets the marked packets and instantly fires the row CNP back to the senders. The senders throttle, smoothing the traffic and completely averting a catastrophic PFC storm. We have reached our final slide. You have configured ECN, PFC, adaptive routing, and WJH. But you must always verify. Use NVIDIA commands like nvshow interface QoS rows counters to ensure your ECN marks are actually happening and that PFC isn't constantly pausing your network. Use the WJH packet buffer command to hunt down lingering microbursts. The ultimate strategy for a high-performance AI fabric is holistic. You need the hardware advantage of the fully shared buffer, ECN for early traffic shaping, PFC strictly as a last resort, and adaptive routing to utilize every ounce of spine bandwidth. Before you deploy, always validate these configs in a digital twin using NVIDIA Air. Thank you for joining me today. I invite learners to like, subscribe, and visit quicktechie.com for premium certification prep, including Q&A banks, full ebooks, audiobooks, full-length training, and interview guides. This final mind map serves as your architectural checklist. To build a true Spectrum X AI fabric, you must master QoS with PFC and ECN, maximize bandwidth with adaptive routing, maintain strict visibility with WJH, and validate everything using NVIDIA inside NVIDIA Air. Master these nodes, and your network will be unstoppable.
Welcome to quicktechie.com. So just type in quicktechie.com here. Then you can go through the material which is provided by QuickTechie. So we have first of all video courses which you can go here and you can find the various video courses across the technologies as well as finance domain. So if you see in Microsoft, we have 8 programs currently running. Next, you can go through the ebooks available. So all the ebooks which are in PDF format today, and you can download this. So let me go through Microsoft certification ebooks. You can click on any of this and you can see this is the PDF available for you to download. So these are the premium ebook mostly available on quicktechie.com platform only. Now the second part is exam simulator. As we primarily focus on the all technology companies and finance domain certification preparation material, so this is company wide listed here and you can go through this. So let me go through the Microsoft one again. You can see these are all Microsoft related certification. AB 730 exam, if you open it, so you can see here this, and all the practice papers are available here. Today we have a 5 practice paper. So click on the first practice paper, it would load the questions. You can answer this question. This is way you can answer it and you can move to the next question. Now, the third material we wanted to highlight is an audiobook. So we started recently with the audiobooks as well, which you can listen on the go. And various technology-wise ebooks are available. And at the last, this is our alumni. These people who are subscribing to our courses and this platform, they are all listed here. And at the end, I wanted to tell you, if you find any course or training or certification preparation material which you want to get us prepared for yourself, please put on the comment section. If you're watching on YouTube, on Udemy, or on this platform itself, quicktechie.com, then please put the comment, or you can even send an email to using this contact us options here. You can directly do the WhatsApp message. You can call us on this numbers as well.